This video will cover standard deviation, how to calculate the standard deviation, and also a bell curve and interpreting what that bell curve tells you in terms of standard deviation. All right, let's start at the top of this page. Standard deviation is a measure used to quantify the amount of variation or dispersion in a set of data values. A standard deviation close to 0 indicates the data points tend to be very close to the mean of the set, while a high standard deviation indicates the data points are spread out over a wide range of values. There are unique situations for where a standard deviation of 0 actually doesn't show the spread of data being really wide and varied. The standard deviation symbol used is the Greek letter sigma. So the formula for standard deviation is standard deviation equals the square root of x sub 1 minus the mean, that quantity squared. Now this first parenthesis, what this means is you take your first data value, subtract your mean from it. So that right there is finding the difference between a data value and a mean, or how far apart that first data value is from the mean, and you square it. And then we take the second data value and find out how far away it is from the mean and square it. And we do this until all the differences between the data value and the mean have been calculated. One thing that needs to be stated here is that the mean has to be known or calculated first prior to creating the standard deviation. Once all of these have been calculated, squared, and summed, then you divide that answer by the total number of data values. I have an example that I have worked out ahead of time. It's a small set of data. The data values are 10, 11, 12, and 12. So we can guess that the mean is somewhere between 11 and 12. And when I calculated that mean, I got 11.3. I rounded it to 1 decimal place as the data is all recorded to whole numbers. So with my mean, I go 1 additional decimal place in my reporting. So to calculate the standard deviation, I take the first data value of 10, I subtract the mean from it and find that that's a difference of negative 1.3. That will be squared on technology. I take the second data value, which is 11. I subtract it from the mean and find out that it's a negative 0.3. My third data value is a 12. 12 minus the mean squared gives me a 0.7 that I will square, and likewise the fourth data value was a 12. So we subtract the mean and square it. Since all of these values are squared, anything that had a negative result will become positive. When I took all of those numbers, squared and added them, I arrived at 2.76. And I divide that by 4 because there are 4 data values. And the calculator gives a result of 0.69. The square root was approximately 0.83. And I rounded this to 0.8 as the data values were whole numbers and my standard deviation should be reported to 1 additional decimal place. So it was 0.8. Now this standard deviation is close to 0. It's not something like 15 or 20 or 200. So I know that my data values are close together. Now that you know how to calculate the standard deviation, I'd like to take a look at the bell curve. This is a normal distribution, and it helps us interpret what a normally distributed population would look like and how to apply and interpret a standard deviation. You'll notice on this bell curve that there are different shades of blue. That's to help us see the different stages of the standard deviation. In the middle, it says 0. That's to represent the mean. You are 0 standard deviations away from the mean. So this line right in the middle is the mean, and as you can tell, it breaks the bell curve up symmetrically. The left side looks like the right side. Then on the bottom, we see a label of -1 sigma. That means it's 1 standard deviation to the left of the mean. The -2 sigma means it's 2 standard deviations away from the mean. So here's the mean in the middle, and it's 2 standard deviations to the left of the mean. And -3 sigma means it's 3 standard deviations to the left of the mean. Likewise, off to the right, we have 1, 2, and 3 standard deviations to the right or above the mean. Then the next piece I want to point out is this 34.1 and 34.1, which would add to 68.2%. In a bell curve distribution of data, 68% of the data will fall between 1 standard deviation to the left and 1 standard deviation to the right of the mean. That's what this bar down below means. Okay, so once again, when you have a bell curve distribution, 68% of the data will be between 1 standard deviation below and 1 standard deviation above the mean. And let's take a look at 2 standard deviations below the mean and 2 standard deviations above the mean. If I were to add the 13.6, 34.1, 34.1, and 13.6%, I would get something that's close to 95%. That tells us with a bell curve distribution, 95% of the data falls between 2 standard deviations below and 2 standard deviations above the mean. And if we look at 3 standard deviations below and 3 standard deviations above the mean, then we can see that there's a total of about 99% of the data. So anything that's beyond 3 standard deviations of the mean would really be unusual and unique.